All right, well, we might as well get started. Late people can catch up. It's kind of a shame, though, because this is an important lecture. We're going to talk about, you've done a bunch of stuff in your branch, you've developed something new, it's good, it's worth checking in, it should be part of master. How do you get it into master? What are the steps you need to follow? I'm sure we're all aware of the fact that Rosetta users and Rosetta developers are a community. We've got about 50 people developing Rosetta and 500 using it, so don't break master. People will get mad at you, particularly Alex, and we don't want this to happen. The good news is Git makes it very, very easy to revert any damage that you might do. You still don't want to be the person who's always breaking master, though, because the whole community will get mad at you. Yeah. So there are a series of steps to follow. Follow the coding conventions. There are certain conventions we follow in the community. There are two types of documentation that are important. Document your code in the code using Doxygen tags, which allows us to auto-generate code documentation. Write unit tests. We also document on the help wiki in natural language how to use whatever you've developed. Write unit tests. If you're making an application, surround your code with try and catch blocks. Write integration tests, which I'm going to go over. They're different from unit tests. Compile in both debug and release modes. There are things that are caught in debug mode that are not caught in release mode. And once in a while, you'll encounter something that fails in release mode but doesn't fail in debug mode. Run your unit tests at least on the test server, if not on your own machine. Run integration tests at least on the test server, if not on your own machine. As I said, make sure it's documented on the help wiki. And then we use something called pull requests. Pull requests should really be called merge requests. They're a message sent out to the community saying, hey, I want to merge some stuff into master. Can you review what I'm doing here? Make sure that all the tests on the testing server pass, or that failures make sense. And then you can push the big green button on the GitHub user interface and merge your stuff into master. So I'm going to cover these a little out of order. Some things we've already covered, unit tests, for example. The rest I'll cover today. I'll start with integration tests. So, integration tests. Integration tests are different from unit tests. Unit tests are testing one module, more or less in isolation, and asking, is this module working correctly? Is it giving me the correct answer? An integration test, on the other hand, is typically testing the interaction between many modules, and it's a regression test. It's just asking, did the output change? It can't ask any questions about whether or not it's giving you the right output, and most likely the trajectory that you've set up for the test is not anything that's scientifically meaningful, so there might not be any particular right output. But we want Rosetta to behave consistently from revision to revision, so there shouldn't be a lot of things changing all the time. An integration test should run a short trajectory, produce some output, and complete itself in about 30 seconds. So first of all, to run integration tests, and there are about 250, 300 of them already, you first run the tests for the master branch, and that generates a directory called ref in the integration tests directory. And then you run the tests for your branch with master merged in. And this creates a directory called new and generates a diff between the two. And if the diff is empty, if the two directories have identical contents, then nothing has changed and all the integration tests have passed. So here are the details for how to run. Go to the source directory, check out master, pull the latest master, compile in release mode. We usually run integration tests in release mode because they're too slow in debug mode. On the testing server, they are also run in something called release debug mode, which is somewhere in between the two. It's a little faster than debug mode, but it catches more things than release mode. CD to the integration tests directory. If you're in the source directory, that's one directory up, tests/integration. And then run the integration tests. And the command is python integration.py-j, the number of processors you want to use. And so that's going to go and run all the tests for master. It'll take a while, and it'll generate the ref directory. Incidentally, if the ref and new directories already exist, delete them before doing this step, because you want a new ref directory. Then go back to the source directory, check out your branch, pull your branch if necessary, merge master into your branch, resolve any merge conflicts. Compile again. Go back to the integration test directory, run the integration tests again. This will generate the new directory and a diff between the two. And it'll tell you which integration tests have failed because the diff is not empty. I'll mention too that these steps can be done in advance. You can pull master and have it have the latest master locally, and you can merge master into your branch and resolve any merge conflicts. And so you've got a local copy of master and a local copy of your branch ready to be tested. So here's how I typically do it. Git checkout master and git pull, git checkout my branch and git merge master. So all of that is done. Resolve any merge conflicts. Okay, I've got the two things, and then I just do it as one giant concatenated command. Go to the source directory, git checkout master, compile. Go to the integration test directory, run the integration tests. Go back to the source directory, check out my branch, compile. Go back to the integration tests directory, and run the integration tests. I usually do this with no hup so that it runs whether or not I log off the dig node that I'm using. And I like, this is just my personal preference, I like to pipe the test of master to reference.log and the test of my branch to new.log. And at the end of new.log, the diff will be there, so I can just check that file afterwards and see what failed. Integration test changes. Any change that you see should be taken seriously, but not every change is an indication that you shouldn't merge with master. The goal is understanding why the changes occur. So if you've just added a new feature, then and you've added an integration test for that new feature, obviously that integration test is going to fail the first time because there's nothing to compare it to. So something has changed. If you fixed a bug, and that bug was affecting the trajectory of one integration test, then you expect that trajectory to change. And so in those cases, there's an expected change that you see. The test will fail, but it's not a bad thing. And you also might have cosmetic changes. I've changed the line of output to make it more informative. Now everything that produces that line of output is going to show a diff and going to fail, but that's what I want. But other things could be caused by errors in your code, by some instability that you've introduced. These are all bad things. Before you merge, in your final merge message, you need to list all of the integration tests that are failing and explain why they're failing. So these tests are failing because I've changed this line of output to make it more informative. That's totally fine. Incidentally, if you want to run a single test, you can just run this script with the test name appended. And if you're using Clang to compile, you need to add the -c Clang flag, or whatever other compiler you're using, -c ICC or whatever. Integration tests are located in main test integration, and then there's a subdirectory called tests, which actually has the tests. To add an integration test, first, add a new subdirectory to this tests directory. Second, create a file called command. It's usually best just to copy a command file from one of the other integration tests. And in that command file, it's just a bash script that runs some Rosetta app and provides some sort of input and tells it to produce some sort of output. Make sure that whatever you're setting up takes about 30 seconds to execute. It shouldn't be a scientifically accurate trajectory. It should just test the working of something. If you want to, make folders for input and output. And finally, create a file called observers and add your email address to it. So with the string master prepended. So in my integration test, I have master my email address. What this does is, on the test server, if an integration test fails, you get an email every time it fails. So if you've created a module and you've covered it with an integration test, you know if someone else has gone and broken your module or changed the functioning of your module. And look at the other integration tests for examples. The other thing I'd recommend is muting any output that's totally irrelevant to your test. So if I've made, I've built the generalized kick mover, for example, and I covered it with an integration test, and in that integration test, I muted all of the output from movers other than generalized kick, so that if something changes in Rosetta scripts or something like that, it's not going to trigger a change in my test. Command file basically tests for the existence of the executable, throws an error if it doesn't exist, runs the executable with whatever flags you've provided, and then checks the exit status of your executable and throws an error if it exited with error status. So there are two ways that an integration test can fail. You can have a non-empty diff, or you can have an error status on an exit. Which does mean that you can write an app that serves sort of like a unit test in the integration test suite. You can have an app that fails if it produces the wrong output. Flags, files, I don't think I need to cover. Just put your flags here. I recommend muting irrelevant output. All of this I've covered already. Any questions about integration tests? Nope. Okay. Moving on, if you're writing an application, all the meat and potatoes of what your application does has to be surrounded by a try-catch block so that we can handle errors properly rather than just crashing. So most of the all of the applications in the public release of Rosetta have a main function that looks like this: try, initialize Rosetta, and then call whatever protocol your application calls. You can put all of the code for your application here if you want to, but it's usually better to put all the code in the protocols level libraries and just have the app call that code. It allows the code to be reused, for one thing. And if you look at things like the ab initio app, it's about 30 lines of code, and all of the complicated stuff is in protocol/ab initio. And so this try-catch says, okay, do this stuff, and if an exception is thrown anywhere, handle it in this catch block. The catch block writes out what the exception is with its error message, and then returns a failure status. And if a failure status is not returned, you return success. Any app that is added, so apps that are going to be compiled by default are listed in apps.source settings and pilot apps.source settings. If you've added an app to that, it has to be set up like this with a try and catch block in its main function. In order to enforce that, we have an integration test that actually acts more like a unit test called app exception handling. And it just goes through all of the binaries in source/bin, tries to run all of them in a manner that produces an error. There's actually a flag that says exit with error status, and tests to see that they all properly catch that error. You don't have to opt into this. It automatically goes through anything that's compiled by default. But you will break this integration test, and you'll break it with a failure exit status if you don't make sure that your app is set up like that.
Just so you know, you're blocking your slides.
I've got a bad habit of doing that. Let me, well, yeah, don't have much of a...
Could you just move your computer here?
Unfortunately, this cable is not very long.
The chair right here.
Yeah, okay, that's good. That's good. There we go. Alrighty. Okay. So the next thing is make sure that whatever you've done is documented on the help wiki in natural language that users can understand, and not language written for developers. The help wiki, I think we've all used it. You can see it at rosettacommons.org/docs/latest. You can edit it at rosettacommons.org/docs/wiki. In order to edit it, you've got to log in with your GitHub account, but it's just like editing Wikipedia or anything else. You can edit it on the website with the GUI. There's no fancy command line stuff that you have to learn. But yeah, make sure that if you add a mover, you've added a page on the movers page, documenting that mover fully. Better yet, give an example as well in the documentation. Same with the filter, same with the task operation, whatever else you add. Make sure it's documented so users can use it. Oh, and it's good practice to document as you go. If you have long documentation that doesn't make sense to be released in the wiki until your stuff is merged into master, but you want to make it as you go, there's a section on the wiki called internal documentation, so you can create a page there and later move it to the appropriate section of the documentation. Yeah, this is just more on documenting an application specifically, but you can all figure out how to do that. Now, in addition to the help wiki, which is for users, we have the Doxygen documentation, which is for developers. The Doxygen documentation, in theory, documents every single variable, every single class, every single thing that's in Rosetta. In practice, it's not quite complete, but it's still pretty good. It's accessible on the Graylab website. Now, in general, no matter what, you should be commenting your code. First, for your own sake. At some point, you will revisit code that you wrote a year ago, and you'll say, what the hell was I thinking? But second, for the sake of everyone else around you. Someone else will probably have to debug your code at some point, and it's nice to understand what you were doing. But in addition to the regular comments, there are special comments. Instead of using 2 slashes, which is the normal way to comment something in C++, if you add a 3rd slash, that's a special comment that Doxygen pays attention to. So Doxygen commands start with 3 slashes, a space, and an @ symbol. And this allows the automatic Doxygen documentation generator to just go through the code, find all the lines that start with this, and say, OK, here's the documentation I should be generating. Absolutely any function, any class method needs to have before it a tag that looks like this, / @brief, with a brief 1-line description of what this function does. Point.x should have a / brief that says returns the x coordinate of this point. If your function does anything particularly complicated, it should also have a / @detailed. Pardon me, sorry, not detailed, details, which can have a much more detailed explanation of what the function does. And then there are other commands that you can include also, like / author if you want to take credit for something, etc. At the start of any file in Rosetta, you should have these 3 lines. You should have what the file is, a brief description of it. You can have a detailed description of it as well, and who wrote it. And the who wrote it is very important, especially include an email address so that if someone has a problem in that file, they know whom they should be emailing. And this I already said, classes, functions, etc. should have brief descriptions, and details is used to provide a more detailed description as well. Yeah, these are just examples of that. There are other tags that are handy. Param is nice if you've got a function with a bunch of arguments, some of which are inputs, some of which are outputs. You can document what's an input, what's an output, what the various arguments do, what's going to be changed by the function. OK. Any questions about Doxygen documentation? Have you seen the Doxygen website? OK. It's handy to have open while you're developing, and it gives searchable information on all the classes in Rosetta. It's kept fairly up to date, too. I think it's generated weekly from master. So the next thing, open a pull request on GitHub. Actually, merging code you can do it at the command line, but we don't do it at the command line anymore. So if you're going to merge into master, do everything on GitHub. If you're going to merge from master into your branch, you can do that at the command line. What a pull request looks like is something like this. Every developer will get an email saying so-and-so has opened this pull request. Here's the short one-line description of what it is. Here's a more detailed description of what it does, what the expected changes are, and then you'll see a list of all of the commits to that branch. And actually, I'm going to go over to the GitHub website right now. Oops. There. And I will show you a pull request that I opened a couple days ago. And I'll show you how to use this in conjunction with the test server, because the test server actually interfaces very nicely with GitHub. So github.com, sign in. OK, so here's the Git page. If you click on main, we'll get the Rosetta repository. If you want to open a pull request, go to branches. And you will see a list of your branches, and you'll see a list of everyone else's branches as well. You can open pull requests for other people if you want to. So here are some of the branches that I've been working on recently. If I've already opened a pull request, I'll see a green thing over here that says pull request open. If I've opened a pull request and have merged it into master, I see a purple thing that says merged. And if I haven't got a pull request for that branch, I can create a new one by clicking over here. To see all of the open pull requests, click on the pull request tab. And here are a bunch of developers who want to merge a whole bunch of things into master. I've got a couple here from the last couple of days. So here's one where there was an issue in our multi-threading code that I fixed. And I want to merge this fix into master. I explained briefly what the fix is, and because there are some people who know more about the multi-threading code than I do, I tag those people and say, hey, can you double check this? Maybe I screwed up here. And we've even had a little conversation here. Rocco has said there's something else that needs to be fixed also, and I said, okay, I'll fix that too. If I want to see exactly what I've changed, I can click on the Files Changed tab over here, and it shows me before and after. Here I'm just changing a couple lines of code, but you might have hundreds or thousands of lines of code changed. If I want to see all of the commits in this branch that will be merged into master, here's the list. In this case, it's just 2 commits. One of the nice things is I can open the pull request before I make many changes, and I can keep adding commits to the branch, and they'll automatically be added to the pull request. So I don't have to open a new pull request if I realize I'm not quite done yet. So I like to use pull requests as my to-do list also, and I list all the things I still need to do, and I check them off as I do them. And finally, over here, there's this labels section. If I click on this little gear icon, I've got a list of labels that I can add here. And you can see I've added these tags bug and question so that people know that I'm fixing a bug. I'm not adding new features. I've got a question about what I'm doing. Other people should take a look at this and maybe answer my question. There are all sorts of other labels I can add to this. They're just for the development community. They don't mean anything, except for this one. This one is special. The one that says ready for testing, that's a signal to the test server. Any pull request that's labeled ready for testing will automatically be sent to the test server to be tested. And that's somewhat computationally expensive, so don't label your branch ready for testing before it's actually ready to be tested. The other thing to be aware of, which is both a nice feature but also something that can get you in trouble, is if a pull request has been labeled ready for testing and you add another commit to it, the new version of the branch is also sent to the test server for testing. In fact, any tests on the old version are canceled and the new version is queued for testing. Which is great if you just need to make one more change to your branch, you realized you missed one thing and you need to retest your branch. But it can be dangerous if you've forgotten that you've left the label on there and now every single version and every commit you add is being added to the test server queue. It can tie up the test server. So just make sure that you use ready for testing carefully. But be sure to label your branch ready for testing before you merge into master. When you're ready to merge, if you go down to the bottom here, there's a big green button that says merge pull request. I can also see the results from the test server. This says all checks have passed. If I want to actually go over to the test server, I can click on this show all checks button and on details. And over here this is the test server now, and this shows the results of the test. Build test, just trying to compile in debug mode. I've got green lights all the way across. I would have a red light if something had failed. Release mode compilation. Unit tests, and these are on different platforms: Linux Clang, Linux GCC, Linux with C++11 multi-threading, Mac Clang. Then up here we've got additional build tests: Windows PyRosetta build, Linux PyRosetta unit tests, Mac PyRosetta unit tests. Lots of other very specific things, looking at the MPI build and the OpenCL build and so on and so forth. And then here are the integration tests in release debug mode and in release mode. And I've got a red light there, so something has changed in an integration test, so I should go and take a look at that. And if I click on it, and I wait a moment, yes. So what I see is a bunch of integration tests have changed. I happen to recognize these ones, and I know that they are integration tests that are showing instabilities right now. So I know that this has not broken anything. However, if you have any questions about why integration tests have changed, you should ask someone. There's also one over here that's failing, and that one has been failing for a while, which isn't good. When an integration test is failing, we should fix it. But I know at least that my changes are not responsible for these. So at this point, I'm convinced that this is safe to merge into master. And so I will do that right now, going back to, back to this page here. For the final merge, what I usually do, sorry, I went back one too far. For the final merge, what I usually do is I copy my description of what it is that I'm doing. So I copy all of this, and I go down to the bottom here, and I click the big green button, merge pull request, and it gives me a space to enter a message that's going to be the commit message for this final merge. So I've got the title here, issue in our thread safety code fixed. I paste all the description, and I'll just add a message here. Only those integration tests that are showing instabilities are failing. And confirm merge. And that's it. Now master has been modified, the master branch is changed, and everyone who pulls master will now see those additional commits. Any questions about how to use pull requests, how to merge your code into master? The other thing is, don't open a pull request and immediately close it unless you're really sure what you're doing. Make sure the community has had a chance to comment on your changes. Does all of that make sense? Your first time through, it might be a good idea to get someone more experienced to just kind of make sure you're following the process. Okay, so use pull requests. The other nice thing about a pull request is after I've merged it, there's a button that says revert pull request, so I can undo it just by clicking a button if I've totally screwed up. And after I revert it, it creates a branch for me to remerge it as well if I want to. So it's very easy to fix whatever went wrong in that branch and then remerge it. It's a little bit harder if you're not using pull requests. You have to do more command line foo. Oops, sorry. Yes, so I've already showed you the test server. I'm just going to go back over there one more time. You can access this, there are links from the help wiki and from wiki.rosettacommons.org. Oops, sorry. And one last thing that I'll show you here is there are these tabs across the top, master, commits, etc. In the commits tab are all the branches that people have queued for testing. And if I scroll down, I'll find that those tests that I showed you. White means tests have not run yet. Gray means tests have been canceled. Yellow means tests are running. Green and red are the obvious failed pass. So here are some branches where tests are running, some of Tom's commits. If I scroll down further, I'll find mine eventually. There's a submit tab at the start where you can actually submit a branch for testing. And it looks like that's what Andy's done here because he's only queued specific tests. He didn't want the whole test suite to be run. And finally, the most important thing is if I click on the tab that says master, after every merge with master, the master branch is tested again. So it's an extra redundant level of testing, and it's important. And you'll get an email if something fails there too. So after you've done a merge with master, check your email and check the test server a day or so later, and make sure that you've got green lights on the master branch as well. Anything that breaks unit tests in master or builds in master can be immediately reverted. We expect integration test changes sometimes, the profile tests. The profile tests sometimes change a little bit. They're not 100% stable. They're supposed to be testing Rosetta's speed over time, but that is showing some spikiness, so, which is just due to the test server itself. So I wouldn't worry too much about that. Yep.
Just a quick question. This is like a little bit of statistic. So if you make a pull request and then you get all your tests, they're going, they're fine, and you wait like a day or two, it's usually, you notice that somebody else did a merge during this day. Normally, what is the classical approach? Well, what we are supposed to do in that case?
That's a really good question. So first of all, if the merge significantly affects your code, such that there are merge conflicts, GitHub won't let you merge that branch. It'll say there are conflicts that need to be resolved, and there you've got to go to the command line, pull the latest master and merge master into your branch and resolve the conflicts, and then retest it. If there have been some changes to master since you tested, and you look at the changes and they're unrelated to your code, and it's reasonable to suppose that they're not going to alter your code, you can probably merge. And this is why we have another round of testing for anything that after it's been merged in master. It'll be caught there. It's a little bit of a gamble. If someone has modified something that looks like it might affect your code, it's probably a good idea to pull for master, merge master into your branch, and retest.
No, because I was saying, if you made some significant changes and then you remerge master into your branch, rerun everything, send it again to the test server, and then if this takes a while, you're again back to the same position and somebody made merged there.
If significant changes were coming in that fast, that would be an issue. Usually the time it takes to test is small in comparison to the time scale on which Rosetta changes significantly. I haven't yet been in the position of being frustrated by having to retest a lot as a result of master changing rapidly. Once in a while I will have to retest once because one new significant change has crept in, but I've never had to do it more than once. Master just doesn't change that quickly. Maybe someday it'll be a problem, but at the same time, we're getting more and more servers for the test server, so the test server's capacity seems to be expanding at the rate necessary to ensure that tests are completed reasonably fast. Okay, the last section, which I'm going to go over very quickly, are coding conventions. Some of these are more important than others. Some of our coding conventions are related to how you use pointers, which means that if you don't follow them, you could be breaking Rosetta or introducing memory leaks into Rosetta or whatever else. Others are just related to human readability, like how we prefer to use white space in Rosetta. They're not so important, and actually we've got some automated tools for just correcting your white space usage. But it is very important that Rosetta be human readable. C++ doesn't care about white space. There are all sorts of ways that you can make C++ code completely illegible to a human, but completely and still be totally compilable. But we want to make sure that our code is nice and readable so that other people can understand what you did. There are coding conventions on wiki.rosettacommons.org and on the documentation wiki. Read them, familiarize yourself with them. I'm going to go over them briefly. Any Rosetta file is supposed to have this copyright notice at the top. You can just copy and paste it from other files. Namespaces. The directory structure in Rosetta matches the namespace structure. So so I told you that recently I moved residue selectors to core/select/residue selector. That directory. I also moved them in their namespace to core:/select:/residue selector. Namespaces match directories. It helps a lot when a developer needs to know where a file is. Pointers. Try to never use raw pointers. So far, I've only had one situation in which I needed to use a raw pointer, and in the end, I was able to get around that. You all saw during the homework that it's very easy to forget to call delete. That means that you end up with allocated memory that's no longer accessible. That's called a memory leak. It's a bad thing. We don't want Rosetta to be leaking memory and crashing. But if you use owning pointers, that's taken care of for you. So use the owning pointers. Arrays, avoid C-style arrays, where you say int x bracket 5. Use vectors instead. For strings, use standard string instead of character arrays. Header files are surrounded by these guards, and they ensure that the header file is only compiled once, the first time that it's included. If you include it, if you've got file A that includes file B and also includes file C, and file C also includes file B, the compiler is going to encounter file B twice. The second time through, it should say, oh, I've already compiled this. I'm not going to try and compile this again. So these guards help ensure that. In some flavors of C and some development environments, there are things like pragma once. It's a command in Visual Studio that says only include a file once. Because that's not universal and it's not standard to the language, we can't use that, so we use guards instead. This is a way where no matter where you compile it, it will work to ensure that your code is only compiled once. Use assertions to test for things that should always be true. And pay attention to debug mode assertions and runtime mode assertions. There are some things where you only need to assert it's true once during development to ensure that the program is working properly. You don't need it to be checked every time the user runs it. In that case, you should do debug mode assertions. On the other hand, there are some things which you need to check are true, which might not be true if the user has provided bad input. There, you should use runtime mode assertions. And one thing I'd say is don't ever use assert, actually. Instead of assert, use debug assert if it's a debug mode assertion. This is nice because it will print out a backtrace if the assertion fails, so that you can see where it failed and what was being called. And if it's a runtime assertion, use runtime assert string message to ensure that there's an informative error message that accompanies the failure of the assertion. So in this case, I've added this error message, error, the residue index provided is outside the range of residues in the pose. The user has asked me to operate on residue 50, but I've got a 20 residue pose.
Do you need to include a special header file for using debug assert?
Yes. And off the top of my head, I can't remember what it is. It is something that most files include, though. So, but
Is it the same as assert? No.
no, it's not the same as assert. It is a Rosetta specific thing.
I have a question before. So when we are writing the unit tests, we use assert and that kind of thing. Should those be debugged?
No, unit tests have their own special assertions. The TS asserts in unit tests are specific for unit tests, and yeah, you should use that in unit tests. Yeah, this is for Rosetta code proper. Should have debug asserts or runtime asserts. An example of where you might use a debug assert is, let's say I've got some function that is just returning an element in an array. And it's a function that's probably going to be called thousands or millions of times in loops. In debug mode, it's fine to say, hey, does the array actually contain this element? Or am I trying to access an element beyond the end of the array? In release mode, I would not want to do that check because it's going to slow down execution of my loop. I just want to blindly access the element in the array. An alternative way of exiting with an error message is this macro in Rosetta, utility exit with message. So you could use a regular if statement, and if the condition is not satisfied, you can print out that message. Warnings. Compiler warnings are not to be ignored. They typically tell you that something is wrong, that needs to be fixed. And in the past few years, we set up Rosetta to actually fail compilation on any warning. So if there's a warning, correct it. Often it's something as easy as a comparison between a signed and an unsigned integer, which means that you just have to static cast one of them. Remove unused variables and functions. If I've got my function that takes an argument and I don't actually use that argument in the body of the function, it's a waste of clock cycles to make a copy of the variable. So the shorthand is just to comment that out. The function will still take a size when you call it in C from somewhere else, but the size doesn't actually get passed to the function. Avoid.
So what's the point of this trick?
So here's a concrete example. The base class for mover defines parse my tag, and parse my tag takes a bunch of different things. It takes a data map and a pose and a whatever else. Some movers use those things. Some movers don't use the data map, for example. If I'm not using the data map, there's no point in passing the reference to the data map. So in the parse my tag in the CC file for that particular mover that does not use the data map, I can comment out the name of the variable. Just so that I'm not bothering to pass an unnecessary piece of data to that function. And the compiler interprets that to mean, yeah, just don't bother making a copy of the information.
Is it possible, if you're reading code, is it possible to recognize when you are in this case or a case in which you can essentially not declare this variable?
Yeah. If you're making a function from scratch and you know you're never going to need that variable, don't include it in the argument list. If you think you might need it at some point, but you don't need it right now, it's fine to include it in the argument list and comment it out. And if your function is implementing a function from a base class, you probably have to include it in the argument list, but comment it out. Now, the other thing too is you don't have to worry about this when you're writing your code. When you go to compile, the compiler will say unused variable here, and the solution is just commented out. Avoid code duplication. If you've got module A that does X, Y, and Z, and you've got module B which also needs to do X, don't just copy and paste the code from module A that does that. Take the code out of module A, put it in a utility file in a separate place where both module A and module B can access the same code. If you declare a public function, you have to define it. Kind of goes without saying. Each class should be in a separate file, and each class should have a header file, a CC file that actually implements all its methods, and a forward declaration, forward.hh. Forward.hh, it should just contain class whatever. It should have no information about what's in that class, and it should contain typedefs declaring the owning pointers for that class. Forward.hh should be included if you've got a block of code that just needs to know about the existence of a class but doesn't need to know about any of the private or public member functions of that class. Like a header file that's taking an object of this class as an argument. The HH file should be included if you actually need to know about the member functions of the class. This helps ensure fast compilation. Avoid global data. Make sure that when you have a new class, you ensure that all of its data are copied in the copy constructor and in the assignment operator, the equals operator. Be aware of const correctness. We talked about that in a previous lecture. Pass objects by reference and not by value unless it's an object that's smaller than the size of a pointer to that object. So a bool, a char, or a core size should be passed by value, or an int, but we try to avoid using ints. And only pass by non-const reference if the function changes the thing that it's operating on. Function signatures have to, this stuff has been gone over in a previous lecture. Avoid long function declarations with long argument lists. If you have a lot of arguments that have to be passed to a function, create a class that encapsulates those arguments. This is no longer necessary. It was necessary when we had our old system of owning pointers. But you should define at least owning pointers for your class in the forward.hh file, and possibly access pointers as well. We didn't really talk much about access pointers. They're not used all that frequently, but we can talk about them later if you like. Avoid multiple inheritance. C++ is totally happy with a class inheriting from multiple classes. So for example, if I had class mammal, and I had class fox, class dog, class cat, and I had class egg layer, and I had class snake, and class bird, and class fish that all derive from that, I'm allowed to have class platypus, which inherits from both class mammal and from class egg layer, because a platypus is a mammal and is an egg layer. We want to avoid that in Rosetta. There are a few exceptions, but the instances in which you use that should be as rare as platypus are. What we don't want is modules that are intended for very different purposes to both be base classes for something. Like we don't want an object that is both a mover and a filter. That would be bad. So in general, avoid multiple inheritance. Don't use protected inheritance. Everything should be public inheritance. Be careful with inclusion patterns. Try to use forward.hh instead of hh if you can. Never include a CC file. Don't include something unnecessarily if you don't need it to, because it'll slow down compilation. Again, the forward.hh file should have class, my class, and the actual class definition should be in the HH file. This line by itself just prototypes the class and lets other things know this class exists, but doesn't tell them anything about that class. All the meat and potatoes of what a class does, all the functions should be in the CC file. The exception is there are some things that you guys know about inlining. So if you have a function in a header file with no prototype, or you just put the function in the header file, and you put the inline keyword ahead of the function, that's a suggestion to the compiler. What it says is, rather than just create one copy of this function in the code that other things call, take the code that's in this function, and when you compile it, just put it directly in line where the function is called. So if I've got line of code, line of code, line of code, function call, line of code, line of code, line of code, when I compile it, what the machine code will be is just line of code, line of code, line of code, and then lines of code from the function, and then more lines of code. It makes for larger executables, though, because it's going to do that everywhere that the function is called. But it's probably appropriate for things like getter and setter functions. If I've just got point xyz, and I've got the function, the member function x that just returns the x coordinate, that can be inlined, and it helps. It makes for faster execution at the expense of larger program size. So getters and setters can be inlined. Everything else should be in the CC file. Includes should have the full path relative to source. Never include a CC file. I think most of this we've covered now. Alex already talked about the library levels. Stuff in protocols can link to stuff and include stuff in core, but stuff in core cannot include stuff in protocols. We have the libraries level script, and the libraries level test on the test server will turn red if you violate this. You can just kind of follow the pattern in existing CC and H files to see what the order of includes should be. Naming convention, we use camel case for class names. Camel case means you've got this Humpty Bumpty thing where you've got everything concatenated together in capitals at the start of each word. And we use boxcar for private member variables with a trailing underscore. So boxcar means you've got a bunch of things in lowercase separated by underscores. Looks like a train. Again, this isn't that important, but yes, use core/types.hh and don't use, try to avoid using things like double and float. Definitely don't use these. The reason is that they have different definitions on different systems, and you'll have different levels of machine precision on different systems. We use core real instead because it's defined to have the same level of machine precision on all systems. And it also gives us a way of globally altering the overall precision of Rosetta if we wish to. Usually we do not use int either. We use core size. Core size is a long unsized int that's guaranteed to be large enough to store all of the indices of the largest vector you can allocate. But it's unsigned. So the one place where you can use int is if you need a signed int that can have negative numbers. So generally avoid int. You can use ints also if you know that this is a situation where I need a short int or something like that. Yeah, don't typedef to float. Just don't use float or double at all. You can use typedefs for conciseness, but make sure that they're within the function. So I can say typedef core scoring score function OP as score function OP within the context of my mover, so that I only have to type score function OP instead of core scoring score function OP. I usually avoid that though. Using namespace, allows you to access members of that namespace without specifying the namespace. You can use it, but again, it's preferable to use it within function bodies, and it's better to be specific about the particular class that you're using rather than including the whole namespace. I try not to use that either. Casting, do it with static cast. Don't do C-style casting where you just put the type in brackets. Static cast lets you search the code for your casts. There is a utility for typecasting owning pointers. It's something like dynamic pointer cast, utility pointers, dynamic pointer cast. Think about thread safety. Don't use non-const global data. Avoid global data in general. Data must be constant after devel init completes. Devel init is called at the start of any Rosetta app. Never, ever, ever use goto. Goto is bad. I didn't even know that the C language had a goto statement, but goto just means I'm at this line number, jump to this line number. There are no guarantees that your program is going to be in a safe state if you jump from one line number to another. You won't deallocate memory, you won't call destructors for things. Don't do it. It's something that old programming languages have, that structured programming languages let you avoid entirely. Avoid macros. This is a very subtle thing, but the convention in Rosetta is to use this instead of this. This has as its return value the incremented value. This has as its return value the non-incremented value. So if I say int I equals 5, y equals plus plus I, that means increment I, so it's 6 now, and then store its value in y. So y ends up being 6. If I say y equals I plus plus, that means store the value of I in y and then increment the value of y. So y ends up of I. So y ends up being 5 and I ends up being 6. So plus plus I is more intuitive. It does what you kind of expect it to do. Avoid unnecessary semicolons. Some of this is really unnecessary. Spacing, if you're worried about white space, run the beautifier. There's a Python script that spaces things out and makes it look pretty. Line characters, use Linux, Unix line endings, not DOS line endings. Indentation, you'll get a sense for the Rosetta indentation style just by looking at existing files. And the beautifier will correct your indentation. Never use and or, use the actual operators. And output to tracers rather than using printf. And don't output to standard cout, use the actual tracers. So each module in Rosetta has a tracer associated with it that has the name of the module. This allows us to selectively mute output from various modules and also allows us to be sure in our output log that we know which module is creating which line of output. And then you pipe your strings to the tracer for that module. I'm going to skip that. And use the utility functions for accessing files. Utility IO IZ stream instead of standard IF stream. And that's it. Any questions? I know I went through all the conventions very quickly. They're all in the wiki. Glance them over. Try and memorize the important ones. And in general, just have someone experienced look at your code before you merge it with master. Yeah, major violations of conventions will be caught thanks to pull requests. Okay.